very annoying. You'll have a lot of warnings emitted in your build. But it definitely surfaces the maximum number of possible bugs, which sometimes with Dialyzer I call misunderstandings. So when either Dialyzer misunderstands me or I misunderstand it. It depends on the day. So when it does build the PLTs, it decides that rather than narrowing to the specific applications that your project uses to put in those PLTs, either directly or indirectly, like via transitive dependencies, it says, no, I'm going to collect all of the apps that are in your OTP install, that are in your Elixir install, and all of your transitive dependencies that you pulled in your project, and build that into the PLT. This definitely takes longer than Elixir's method, but the built OTP and Elixir PLTs are put in your home directory, and you can reuse them across projects as long as your versions aren't changing. So this greatly cuts down on those unknown type or function errors that you might encounter. And then for filtering warnings, it's based on match patterns. So if you've ever done like /select or used /funda-ms in the shell, you'll be familiar with what match patterns are. If you haven't, I definitely encourage you to get into them. But it does require you to understand what data Dialyzer returns, but you can get really precise on how granular you want to filter out particular warnings. And then you can also decide that, hey, if I move this function around either into another file or to another line in the same file, it's not going to produce a new warning that you have to change the ignore again. So downsides, I wrote it. If that's a concern for you, maybe it should be. It does create big PLTs. This can be a concern if you're worried about disk space usage. That said, we automated creation of PLTs in our base Docker images that we use in CI. And they really only add about 10 megabytes to the image. Now that's still like big for a Docker image, but this is only for development and continuous integration. We don't ship that. So lastly, of course, it's not very popular in comparison to Elixir. But because it's pretty stable, I don't push new things to it that often. The last one I want to talk about is mixed Dialyzer, which is actually not available on HexPM. I just checked the other day. But this is not really production ready. It was a Google Summer of Code project last year that I helped mentor. It was written by Gabriel Gattu. He's a student, or was a student in Finland. But he's already integrated a lot of the Elixir-friendly warnings that Elixir had. So that's a good place to start. The things I want to highlight from this are a few things he chose to do differently in the design that could be stolen for the other two libraries. First, rather than using the mix project config as a configuration for Dialyzer, there's a separate file. So similar to the mix formatter, you can say what files you want to format, what sort of other formatting rules you want to import. He did a similar thing by having a separate file. And then second, it has this really, really useful Dialyzer info task, which tells you a lot about which warnings are enabled, what they mean, and what applications will be included in your PLTs. So here's a quick code sample of what his Dialyzer EXS file might look like. It's basically a keyword list of all the things. And you can turn on particular apps to remove from your analysis or your PLTs and include. You have a section of warnings that you can ignore, warning classes that you can turn on or off. And then he also said, well, maybe you want to include some extra path that's not on your code path normally to include some other project. So that's pretty useful to have separate from the mix file. And then there's the Dialyzer info task. So it starts off and shows you what your application name is, what the Erlang applications it's going to build in that first PLT, and then what Elixir applications it's going to build on the PLT on top of that, and then all of the project applications that you might depend on from whatever layer. So you get listed everything that's being included in that, and that kind of gives you an idea how big those things are going to be, as well as what might be missing. And then it goes through and talks about all the warnings that are turned on and all the warnings that are ignored and what they basically mean when you counter them. Okay, so that's enough about the tools and like why you might want to use Dialyzer. Let's get to the fun part, which is the chem analysis or bugs I found in Elixir and Dialyzer. And remember, these are possibly misunderstandings, and you'll see why. So the first bug, earlier, I mentioned that underspecs flag found me some bugs. This is the first one that I found that I really want to talk about. And again, like I just said, many bugs found by underspecs are more misunderstandings. But to understand why it happens, we need to know about how protocol modules are generated and consolidated. So hold on to your butts. Okay, so protocols. How many of you have written a new protocol in Elixir? Okay, a few hands. How many have implemented a protocol for new data structure? A few more hands. Okay, so when you define a protocol, you're basically making a contract. And then what the Elixir compiler does behind the scenes is figure out all the implementations of that protocol and dispatch to them automatically when you call the generic function. So this is a key way to add open-ended polymorphism around your data types. So this is part of the code that gets generated when you call def inside your def protocol. So def protocol defines a module. It undefines the kernel def, which defines functions. It's sort of fun. And so in this particular macro quotation, it calls kernel def directly to define functions rather than protocol callbacks. Okay, so when you define a new callback, this code gets generated. It captures the name of the function and the arity into a module attribute that it uses later, and then defines a clause that doesn't dispatch to anything, which is sort of used for the specification in documentation. So that's extracted by the docs tools. And then what it does with the actual implementation is it figures out what the implementation of the particular implementation for this data type, and then dispatches to that function in that module, passing the arguments. So that's basically how protocols work. Find the implementation, call that function in that other module. So you basically have an overhead of about 2 function calls for every protocol call. Okay, still with me? All right. So how do we find the implementation? So we go down to this impl for. So if it doesn't find the implementation, it raises protocol undefined error. Oh, yeah, I'm sorry about the notifications there. I should turn that off. Bye. Okay. So if you've ever had that happen in your code where you pass a struct or something to a protocol that it's not implemented for, it raises that protocol undefined error. And then the next thing it calls is the non-bang version of this function. So it calls impl for, and if it finds it's a struct, so it's pattern matching on that underscore struct field in the map, then it'll call this struct impl for, which is the next bit. And in that struct impl for, it constructs a module name and then says, is there an implementation for this particular module name? So if we go down to the bottom, we see, is this module compiled? Is it loaded into the virtual machine? If so, does it have that function exported, this underscore impl function? This particular function is injected when you do def impl. Excuse me. So if it's true, then it calls, give me the target module for this. So it calls that underscore impl function. Otherwise, it dispatches to any impl. So if you have fallback to any, it's going to use the generic implementation. Okay, oof, that's a lot about how protocols work. No Dialyzer yet. What's going on? In addition to that particular set of dispatch code, it also generates some boilerplate sort of metadata embedded in the module that you can call later. So this is not about specific implementations. This is still in the protocol definition. Okay, so here's where Dialyzer found the bug or misunderstanding. I have a quick look at the specification and the clauses of the function and make a guess at what the discrepancy was. Okay. Everybody have an idea? Okay. If you guess that the spec said it could return a Boolean, but it actually only returns false, You're right. Interestingly, after consolidation, this problem still exists, but in the reverse. It'll only return true. So dialyzer is saying this is not, or this is a supertype of the success type. So the success type only contains true or false, depending on consolidation. It doesn't contain both true and false. Okay, so how will we fix this? Again, it's a misunderstanding. Technically, that spec is true. That spec is correct. It's just wider than the spec that was actually successful. Okay, so to fix this, the first change was to change the generated specification, so it just says false. But this becomes a problem after consolidation. So consolidation, what it does is it replaces that struct impl for with individual clauses for every single type that you've defined. And this makes dispatch a lot faster. So during the consolidation phase, it iterates over the protocol module and all of the abstract forms in it and rewrites those things. So we have to go and replace, and this is some really intense code that I'm not going to spend a whole lot of time on, but we have to go and replace this false, see, we've sort of ignored what the type is, but say, yeah, we consolidated it, and we're going to say that it's true after consolidation. Okay, so beware a little bit of the Erlang abstract syntax here. It's a little scary, but this is basically just a recursive function that goes across the entire syntax tree. It rewrites that. Now, in retrospect, it probably would have been better to just remove the specs entirely and let Dialyzer infer them. But if I recall correctly, core team wasn't really amenable to that idea, and nobody really wanted that. They wanted the documentation or something. Okay, on to bug number 2. Turns out we got this sort of underspecification problem again in Elixir 1.5. The fix for this was released in Elixir 1.6. Turns out they added a new clause to that underscore protocol function again about implementations of the protocol. So they updated the boilerplate here. Before consolidation, it returns the atom for the impls. So this is listing out the implementations of this protocol. It returns the atom not consolidated. So at least they didn't make the same mistake as last time. Rather than like the union type of not consolidated and whatever it returns after consolidation. Oops, whoa, that went to the end. Give me a second. Out the implementations of this protocol.
Extra metadata, so you can do all kinds of really interesting stuff. Like if you could put like a worker ID in a PID, and then you always know worker ID 7. You don't have to put it in every place, every call site you log. So that's really useful. And you can steer the log message based on the metadata. And actually, in the OTP logger, you can steer it based on log message format. So there are some differences. So the OTP logger does the entire formatting at the call site. Logger only does the format string arguments, and then it kind of passes the log message with all the metadata, the timestamp, a bunch of stuff through the pipeline. So it has a richer structure in the message that it passes. For each handler in the OTP logger, you do a separate format step, which means that if you have 10 handlers, you're going to run formatting 10 times. Logger, however, only does it once, and then it passes the result to each backend independently. Each handler in the OTP logger now runs as a separate process. Logger used a gen event for several backends, just like error logger did. And the filters are a little bit different. They're a little bit, they're not the same as how you could trace events in logger. So here is my chicken scrawl on how I understand these different pipelines to work. We're going to cover them. Hopefully you can read this relatively well. So we'll start with our old favorite error logger. So in the calling process, it just literally sends everything over an asynchronous message to the gen event, which has multiple backends, or some number of backends installed into it. Each backend does the formatting and then writes it to wherever it's going. So you only have one message per event, but you do have n formats per event, and the message size is unbounded. So you potentially are sending a very large message, and then you are doing unbounded formatting in the memory space of the gen event handler, which is If that takes a long time, then you have the mailbox growing because all this other stuff is backing up behind it. Yeah, so you can see how that would fail under load. So then logger, the formatting is done in the calling process once. Then we send a single asynchronous or synchronous message, depending on the overload state, and the metadata to the gen event. Each gen event has a backend. The backend does basically a meta formatter where it takes the main log message and then the metadata, formats that however it wants, and then writes it. So you get one message per event, one format per event. You get a bounded message size. The logger formatter does not allow you by default to make a message that is larger than 1 kilobyte. It is forbidden at compile time. And then you do, the only ON operation is doing the metadata formatting, which is relatively cheap usually. You could probably, there's probably enough rope to hang yourself there if you want to, but it's not as easy. And now we have the new OTP logger, which looks quite different. As you can see, we format in the calling process, but we do it a variable number of times. And then for each formatter, we send an asynchronous or an asynchronous or a synchronous message, depending again on the overload state, to the backend. The backend then just simply writes to wherever it's going. So we have n formats per event, we have n messages per event, and we have an unbounded message size by default. So there's, you might see there's some concern here. A lot more ON here than logger had. So we'll see some of that in a little bit here. So structured logging, this is great. This is my favorite feature of the new OTP logger by far. So basically you can log a tuple or a map, I guess, of data. It's called a report. Each report has a default formatting function applied. So effectively, you attach what unless somebody else overrides it, this is how we're going to turn it into a textual piece of data. You can override it, which is great. And a huge improvement here is all OTP messages are now specified as reports. They are not format argument strings anymore. You don't have to parse format string to figure out what kind of OTP error you're getting. You can now look at it as data and say, hey, that's a gen server crash. Big improvement. And structured logging just gives you a lot more options. You can look at the data, you can slice it, you can dice it, you can transform it a lot easier because now it's data and it's not some kind of like format string you're intercepting. So here's a quick example of gen server crashing. So you see it's a map. The label is gen server terminate, the name of the process, the last message the process received, the state of the process, that's the one that might blow you up. The reason it crashed, the client info, which I think is why the client that was talking to the gen server when it died. I actually don't remember how that thing works. And then crucially, we have some stuff like domain OTP. So we know that this came from OTP. OTP is originating this message. Here's the default report callback, which is gen server format log. And then there's some, I really don't know why that's there, it feels redundant, but something about error logger is there. Okay, backwards compatibility, of course. Fair enough. So that's why that's there. You don't really have to pay attention to that. So now, let's quickly talk about filters. Filters are, I really think of them, they remind me of writing like firewall rules for IPFW or PF. Really, you have basically, the filter can ignore a message, which basically just passes it through. In almost all cases, it can drop the message. It can say, I really don't want that. Or you can actually alter the message and transform it or do something to it and return the new message. And you chain the filters together, so it runs down the list of the filters you've got. And basically, if the filter makes it to the end of the chain, it gets passed on to the formatter. Unless the last filter in the chain returns ignore, at which point there's a configuration variable that will decide whether ignore means drop or pass. I think by default it passes. There are actually several filter chains. You have a primary one which is global to all handlers, and then each handler can have its own chain. And it runs the primary first, I think, and then it runs the per handler filter. I'm sure I'll be corrected if I've made a mistake here. And then filters are fun. You effectively, you pass in some state with them. but the state is static. The filter has no ability to update its own state. You could probably put an ETS table in there as the data to pass, but you have to be aware that this filter might be running in multiple processes at multiple times, and so you might have a data race there. So by default, I think traditionally you would just have a fixed value there. Probably do some weird stuff, but be careful. And there are several nice default filters included in the standard library in a file called loggerfilters.earl. So unfortunately, as we've already mentioned, backwards compatibility is a thing. So the new logger looks a lot like error logger. It does not have oversized message protection by default. It looks like the old error logger. So all my complaints around, scaring users are still there. It has two bundled handlers, the standard handler, which is basically the console handler, but you can actually configure the standard handler to be a single log file that if you delete it, it will recreate, which is good. So you could do external rotation on it, and it should mostly work. And then my old friend disklog is still kicking. I've already complained about that. I would say if you are going to use the new logger, please read the documentation and please configure it not to be in legacy mode, because you can get better formatting, you can get better behaviors if you don't care about being compatible with error logger. So don't just blindly turn this thing on. I would suggest you look at how to use it and configure it correctly, because backwards compatibility is a thing, but you only have, as long as you're aware, you can disable that. It's kind of like being no compatible mode in Vim. So you can use an editor that's newer than 1974. So what's next for logger? Basically this new OTP logger has largely removed the reason for logger existing, which is good. However, there is still a lot of users of logger out there, so we have to figure out how do we get them off using logger. And logger has 8 years of development ahead of the new OTP logger. So it has all kinds of features. If you look at the logger README, it's extremely long now, because every time we add a feature, we add it to the README file. So the README is now probably 20 pages long. So logger is ahead on features. There are some really nice features that definitely don't exist yet in the OTP logger. So today I'm announcing, it's not out yet, but Logger 4.0 will be coming out when I get enough time to finish it. I have a branch, but it's not, it actually works, but it's still working on it. We're going to deprecate Logger's event core in favor of the OTP logger. The infamous parse transform will have a mode to rewrite all of Logger's calls into the OTP logger call format, and it will rewrite the metadata, put it in the right format. It all works. I already have this all working. I also have a report callback for formatting the OTP structured logging in the logger style, where it rewrites the big scary messages into slightly less scary messages. I have a bridge, so if you have an existing logger formatter, you can use it with the OTP logger with a little shim. And I think I'll probably try to provide some tooling around migrating and maybe sanity checking, or it's a little tricky, but I'd like to make it so it's easy for there's a smooth transition. If you have any ideas, please help me, because it's kind of complicated to change from one logging library to another. So this is kind of the cheat sheet, I guess. If you have an existing logger project and you want to switch to the OTP logger, these are really the handful of things you need to do if you want it to look exactly the same. So you effectively change your default formatter to the, and this is not going to be easy to print, obviously logger formatter. I'm sorry. And then if you want to overload the report callback to format the crash logs to be slightly more palatable, there is a logger formatter report callback, which will fix all of the OTP reports to look like logger prints them. And then in the logger stanza of your sysconfig, you will tell logger to use logger. And I know it sounds ridiculous, but what am I going to do? And then in your rebar config, and this is for rebar 3, I have no idea about any of these other things, so don't ask me about Erlang.mk or Mix. I have no idea. I don't even know about rebar 2, but just use rebar 3, and you just put this in here, and all of your set dependencies will also be recompiled to use the new OTP logger APIs. It just, if they used logger, they will now use logger, just like the flag says. So it will just upgrade. And I've done this, and it works great. So why are we not keeping this thing alive? Well, we have a new one. It's fine. I don't want to split the community. I don't want to duplicate effort. I'd rather put features, missing features into OTP than keep maintaining my own thing. You know, everybody using the Beam can take advantage of the new logger. If you're using my logger, it's not so easy. It's kind of a weaker story. Also, it's been 8 years, 9 years. I'm fine with being done. Like, somebody else, like Ericsson can have fun maintaining the logging library again. It's good. They haven't maintained error logger very much, so this is fun. So, community involvement. If you have any stuff using logger, if you've written your own backend or whatever formatter, the formatter you can just use with the bridge, but the backend, because the pipeline is different, you get a different thing. It's hard to provide a wrapper. So probably port your stuff. If you maintain a library that's using my logger, please consider porting it to use the new OTP logger. Be aware that you will break anybody running OTP 20 or earlier. If you're using logger, try my branch. See what works, see what doesn't work. And if you try to use the new OTP logger, please let Ericsson know if it doesn't work or if it doesn't address your concerns. I've talked to Siri, and they seem very interested in just knowing about what do users expect. That, you know, they have a very enterprise and Ericsson view of the world, so I think they're open to other perspectives. Also, if you like to do blogs or podcasts or whatever, like, talk about this stuff, write documentation. The documentation is a little sparse right now. There's not a lot of good examples. Fred wrote a good blog post about doing structured logging, which I think is really good. There is documentation, it's just a little thin, like especially like filters are not well documented right now. So, you know, pitch in if you can. It's going to be tricky to upgrade, but I think I think basically we should shoot for OTP 23. That'll be 3 major releases with the new OTP logger available. So next summer, I really think that we should expect our libraries to be using the OTP logger APIs. After OTP 23, I would like to cut logger 5.0, which would not even have an event core. It would be whatever bits that we haven't managed to get into OTP by then. That's all it would really contain. And just be aware that Erlang users like to stay on old versions, so they might get mad if you break their code by changing the logging API. Obviously, they have to come along at some point, but yeah, they will complain if you're not careful. So I wanted to wrap up by doing some benchmarking. This might be a little controversial. I've tried to be fair. My benchmarks may not be completely accurate. Benchmarking is really hard. But I had some old benchmarks laying around from 2011 that I dusted off to see what it looked like. So the two are cascading failures is an application that Fred wrote when he was at AdGear that emulated the failure mode that was killing nodes for them. Effectively, a process opens an ETS table and then spawns a whole bunch of children that all reference that ETS table, and then after a little while it kills the ETS table. All the children try to read from the ETS table, they all blow up, the entire supervisor tree crashes, it all gets restarted, and it all happens over and over and over again. Crucially, it happens slowly enough that the supervisor does not hit the max restart intensity, and so it just really pummels the node until it runs out of memory and crashes. And then Logbench is something I wrote that basically just has different message sizes, different log backends, and basically it just sends a whole bunch of one kind of message through to a backend from a variable number of workers. So basically for cascading failures, I just wanted to look at the memory usage of 5 minutes of endless crashing. This test did kill error logger back in 2011. I don't think it dies now because of some of the depth limiting that's been added, but I didn't bother re-benchmarking it, to be honest with you. So this is logger 4.0, alpha, whatever. Now the graphs are the units are going to change on the graph because I couldn't figure out how to configure RRD tool. But basically you see that we stay basically below 120 megabytes. This is 5 minutes, and you can see each death spiral begin and over and over again. Now, one thing to note is logger in this mode is writing to 3 different log files and to the console. It's has 4 handlers installed. This is console only, and you basically see that we just use very slightly less memory, but it looks very similar. The graph just does its own thing, but look at the axis, not at the height of something. And then if we look at the default config for OTP 21.2, it's not quite as pretty of a story. It spikes up to 600 megabytes, and then I think it realizes it's in some kind of terrible mode, and so it starts to kind of control things, but we still get pretty high spikes comparatively. Like we were at 120 megabytes, but you know, most of the time here we're well above that, or we stuck above that very, very frequently. Then I tried turning on the max size and car limit, and this looks great, except we get almost no logs. It just, I don't know what, I think it goes into drop mode. Something is too slow or too much memory, and basically we get maybe 1/10 of the logs that we would expect. This is with the console again as well. I tried to write my own formatter, and then I don't know what happened. It said flush 5,000 log events, default switch to drop mode, and then all my memory went away, all my CPU went away, and my computer hard locked. So I don't know what's going on here. This is probably something I need to look into some more, but it's a little hard when you can't actually debug it effectively. So this might be my fault, but be aware that strange things happen with this test if you write your own formatter. I don't know why. We'll look into that. So yeah, I think I covered all this. Yep. So on to Logbench. So Logbench just sends a bunch of messages of different sizes to the back end and sees what happens. So this is with one log worker. Just for completeness, I'm benchmarking error logger here, just for old time's sake. And we have 3 different message sizes. So we have simple, which is a very small message, small, which is, I'll cover the sizes later, and then large. And you see that the performance, and this is effectively number of messages cleared through the pipeline per second. That's what the number is. It's not necessarily logged because these different loggers will do different things under overload. Some will drop, some will not. This is effectively at what point does the pipeline clear up? So we're really think about a pipe. How many logs flow through the pipe a second? Some of them may go into the sewer because they're overflowing, but the whole point is how fast can we clear them out of the system? So we see that logger itself is pretty fast here. It's one worker. The other thing that's interesting, we have error logger file, error logger console, logger file, OTP logger console, OTP logger file. Then we have a weird hybrid that uses the OTP logger pipeline with the logger formatter, which is the one that hard limits to 1 kilobyte. So we have 2 of those, one for console, one for file. And then we have the configuration where I've configured the built-in OTP logger size message limitations. And so you see that when the messages are large, and they're not all that large, but when the messages are large, you see that error logger and the OTP logger in the default configuration basically grind almost to a halt. Not quite. They do 22 messages a second, which is pretty slow, but they get pretty overloaded. And you'll see that my weird hybrid is actually the best under load here. And then just regular logger file handle does all kinds of tricks to be asynchronous and tricky, so it's actually very fast. When we have 4 processes logging as fast as they can, the OTP logger gets a big speed bump because it's doing the formatting in the caller. Error logger is still sludging along because it still has that broken pipeline. But you see that the other things have caught up. Logger is not that much slower with 4, or it's actually faster. Everything's faster, basically. But you'll see that the large number of messages, we've gone from 20 to 90-ish for the OTP logger. For the inbuilt size limiter, we've gone to about 2,000 per backend. Logger is about 6,000, 6,500. But then my weird hybrid is kicking ass over here for some reason. It's doing great. It's completely crushing everybody else. And the trend continues at 100 log workers. Again, Logger is basically kind of at the same level all the time. It's not really changing a huge amount. The others basically get faster. Again, though, you look at the large messages, you can only get about 100, 115 for the OTP logger. When you've got the rate limiting installed, it's only about 2,600 versus you get 10 times faster with with my size limiter, which is interesting. And then I tried to send really, really big messages, huge and giant. We'll cover how big those are in a little bit. But again, I could only benchmark these two. The others do not actually survive. It takes so long that I gave up. I had to run these benchmarks a lot. They took hours, but I only had so many hours to run these things. So we're clearing about 5,000 messages a second with the hybrid, and Logger is going about 1,500, 2,000. That's with one worker. We go to 4. Weird things start to happen. You see the red getting tall like that means that actually we're not writing every log out now. We're starting to shed load. And then at 100 workers, we go into like panic mode, and we just start throwing stuff out the window, which is fine. That's good for the system. I mean, you can't necessarily expect to log everything. So you will run the overload condition, and very few of these logs actually get written. But the point is that they're getting flushed out of the system. They're not eating your RAM. They're not eating your CPU. The logging is not consuming all resources on the beam, which is, in my view, important. So back to the large files, large messages. I graphed the memory usage of the OTP logger in console mode during the test, and you see that it goes up to about 900 megabytes and just sits there for the duration of the test. Similarly for the file. This is in the default configuration. So be aware that you may use a lot of memory with the default OTP configuration for OTP 21. The others were much lower. I didn't include them because they weren't super interesting. But these were the outliers. So just to cover the sizes, simple message is 5 bytes, the small is 56 bytes, the large are about 96 kilobytes, the huge are 4 megabytes, and the giant are 16 megabytes. And as I said, Logbench is measuring the flow of messages through the system, not necessarily that they made it to the endpoint. Overload protection may have kicked in. I could have turned off overload protection, but I was kind of interested in what is the default, what do these things do by default? So one thing that we learned here is that the built-in OTP logger message size limiter is really quite slow. I've talked to the OTP team about this. They're aware of it. They're working on it. 21.2.6 is faster, and then there's a branch that's even faster. They're working on it. It's still not as fast as the thing that I hybridized together. That's still a winner, but they're working on it. They're aware of the problem. They've seen this benchmark. They're aware. Yeah, so without message size limiting, you're gonna get yourself into trouble. It doesn't take much to start things kind of getting into a bad feedback loop. Good thing is that the OTP logger does ship with overload protection by default, so it will start to shed load at some point, but you may only get 20 messages a second out of the thing. So just be aware that there are some speed concerns. And as I said, the weird hybrid is the fastest thing. Not exactly, well, it makes sense, I guess, but because my size formatting or my size limiting is much faster, but because I spend a lot of time on it. So that's an interesting thing to take away. So yeah, here's the wrap up. Logger is still, the OTP logger is still pretty new. It still needs work, and it still needs users to give feedback to Ericsson to say this is something that I need or this isn't working well. It's also got some features or it's also missing features comparable to Logger. So if you switch, you may be missing features, just to be aware. I don't categorize the default configuration as safe. I know it's backwards compatible, but I urge you to look at that config and change it because it will bite you in the ass at some point. The other thing is if you have a lot of handlers installed in the OTP logger, they all cost. They all incur a cost versus you can have a lot more handlers installed in Logger and they're relatively cheap. So if you're currently using Logger, be cautious about switching just yet. Take your time, categorize what the performance is going to be like. If you're using the OTP logger already, just check your configuration, beat on it a little and see what it does. If you're still using error logger, just anything is better, please. Just upgrade, please. And I think my real takeaway from this talk is let's try to get everybody working on the OTP logger. Let's put all the effort behind that thing. Let's make that thing better and stop having so many out-of-tree log libraries. Let's just make the standard library logger better, and everybody wins. That's my talk. I don't know if we have time for questions.
We have 4 minutes for questions.
All right.
So what are your thoughts on, I'll say, modern supervisors, like systemd with logger D, like a journal D, or maybe Kubernetes with its own logger? So with journal D, we would be maybe writing to a Unix domain socket instead of a file, and theoretically we can send as much data as we like, but then it fills up. And maybe we could even be writing from all the processes at once, so we don't have a central bottleneck. If you could repeat some of it.
Yes, the question was systemd and Kubernetes, and if you're not logging to a discrete device like the console or a file, can you maybe just avoid the bottleneck? And the answer is yes. I mean, I don't like systemd, and I don't think it's good, but it does, if you want to do it that way, and you can push your logs just over UDP and it's not a blocking interface, you can do that all day long. And in fact, what you can do is you can use a filter to send, your filter can instead never actually forward to a handler. You can, in the filter, just send UDP. You pass the socket in as a filter argument, and you never leave the calling process. So the calling process is just sending UDP. Now, of course, if your UDP stuff can break or do some weird things, you might have trouble, but you don't always have that luxury, though. And obviously, at some point, queues are there's always an unbounded queue somewhere or a queue that's going to fill up, and it's always going to get you someday, whether it's DNS or it's UDP or it's the switch, getting clogged with log packets. But sure, don't log to disk if you don't have to. If you have more infrastructure for that, ship it off somewhere else. Absolutely.
Can I add something to that? Actually,
sure.
Handlers are called in the calling process. There's no implicit process hop when doing a handler.
Oh,
so
okay.
The process hop is something that the handler implements and not something that's part of it. So all the filters and all the formatting and all the filters on the handlers is done in the calling process. And then the process hop is something that you implement there, because we do logging in LTTNG, and then we do these things that they talk about there.
Okay, so just for the record, I have a mistake in my slides, and there is not always a message passed to the handler. I think that's part of the overload protection mechanism. You can write handlers that do not use that behavior, and they will not make a message call, which is good.
Have you run the benchmarks on 22RC?
No, I ran out of time. Sorry, and also it came out after I was done. I was sick of benchmarking. I will probably put together. Oh, so the question was, have I run them on OTP 22RC1? I will probably put all this together in a blog post and try to be a little more scientific about some of it. I ran out of time, but I will benchmark OTP 22 as well.
One last question.
It's okay if you don't know this.
Will I get a red card?
It's like an Elixir thing. No, you're getting a green card. You said the Elixir logger is using the OTP logger underneath, but does that still have the legacy configuration when it ships, and you have to do some weird like Elixir sysconfig doubles?
The question is, does the Elixir logger ship in legacy mode? I don't know. I would encourage you to find out. Because, yeah, things.
I know they don't use our logger at all yet.
No, they do. They do.
In parking, they take our messages, but they still have backward compatibility issues with their interface, so it's not all in there.
Oh, okay.
So the answer is undecided, it sounds. Okay.
Okay. Thank you, Andrew.
Thank you.